Okay, so I'm outside. Here's my backyard. It's a dangerous hill. Don't go down there. Oh! Thought I'd do some work out here, so we'll see how this goes, right? Gotta switch it up a little bit. Horse face was just too much. All right, so let's see. I can't even figure out how to do a video. We're looking at this problem here where they're talking about males having a speech impediment compared to females. It says assume conditions are met. Woohoo! That means we don't have to worry about random, normal, or independent. So we can just jump on in at the O5 significance level. So that is your alpha. All right, so O5, do the data provide evidence of hypothesized developmental differences? There's the wind. Okay, this might have been a bad idea. Okay, so we have male, female, so there's two proportions. We're doing a test, right? So we need to go to Stat World. Tests, and I'm looking for a two proportion z-test. Glare. All right, so the first group will be my males. We had 22 that had a speech delay out of 302 males. We're comparing that to females. We had 78 who had speech delay out of 337 females. We're looking for evidence of developmental differences. So they don't care which way, greater than or less than, right? So any difference at all. So I'm going to choose the does not equal to option. Boom. All right, so here we go. Calculate. Looks like we have a p-value of, woo! Look at that scientific notation. You've got e -8, so that's like 0.000000036. So essentially a p-value of 0. So yeah, we have evidence. We have evidence that there is a difference going on between males and females. Part B says to construct that 95% confidence interval, and how does it compare to the test? All right, so head on over to Stat World, and this time we're looking for interval. So I'm going to scroll down to two proportions z interval. There we go. Since I just ran the test, your calculator will automatically pull these values over. Wasn't that nice of you, T.I. Joe? Yes, it was nice. All right, and it does say 95% confidence, so 95% is my C level, and so I don't have to change anything. I just hit calculate. Boom. All right, so if we look at it, it's an entirely negative difference. So going from negative 21% to negative 10%, an entirely negative difference. All right, let me jot this down so you can wrap your brain around that. All right, so if we are comparing boys to the proportion of girls and we're getting entirely negative, which one of these numbers is the bigger number? It must be this one that's the bigger number. All right, so that would tell me that the girls are the ones that are having the deficit more often than the boys. Interesting. So how does this interval support the test from part A? Well, part A, we said, yeah, we have evidence that there is a difference. So if we think about what the null hypothesis is, that when we compare boys, girls, I should use M and F, shouldn't I? Male, female. Oh, well, we're good. The null hypothesis would be that there's no difference, whereas the alternative is, all right, when we analyze them, there is some difference. And we had a p-value that was essentially 0, so we were able to reject the null hypothesis and go ahead and conclude that there is a difference. There is a difference. All right, so all of that was done with our magnifying glass. When we got down to B-boy, we picked up our net to try and scoop what the truth is. And when we scooped it, we found that the true difference was negative, meaning the girls had a higher proportion of speech delay than the boys did. All right, on to part C. Is this an observational or experimental study? Justify your response in a few sentences. When you go back, this sounds to me like it was just observational. They weren't telling anyone to do anything. They were just watching the children as they developed and made note of what was going on with their speech. So this would be definitely observational. Describe a type 1 and type 2 error in this setting. Which is more serious and why? Okay, so for type 1, type 2 errors, the way I remember it in my head is by doing a Hot-Hoff chart. Hot-Hoff, meaning the null hypothesis is true, the null hypothesis is false. Then, when we think about these significance tests up here, there's only two options. Either we reject the hoe, or we fail to reject the hoe. All right, so those are the two options when we run these significance tests. Either we have the evidence or we don't. All right. So if the null hypothesis is false and we reject it, good for you. You got rid of something that was false. If the null hypothesis is true and you didn't get rid of it, good for you. You did it right. But if the null hypothesis is telling the truth and we kick it to the curb, oops, that's a type 1 error. If the null hypothesis is false, but we don't catch it, we don't catch the lie, oops, that's a type 2 error. All right, so now we need to describe it in this setting. So type 1, error. All right. Okay, so the null hypothesis is true. So when I come back up here, it's true. There's no difference between genders and speech delay. But what do? We conclude that there is a difference. All right, so down here we would say, we conclude there is a difference between genders when really there isn't. All right, so what happens when we do that? Well, let's see, boys or girls might get extra help with speech impediments or delays when really they don't need any help. So we're spending money when we don't need to spend money, but what's the harm in that, right? Better safe than sorry, I say. So as far as which is more serious, I don't think that one's so serious. There's nothing wrong with getting a little extra help. All right, so then let's wrap our heads around this type 2 error. Sorry, this is super sloppy. I'm trying to do this with one hand. All right, so type 2 error, the null hypothesis is false. So if we come back up here, so it's false. There are differences. All right, so this idea that there's no difference, nope, that's not true. All right, so there are differences, but we fail to reject the null hypothesis, so we don't catch it. So there are differences in speech delay between male and female, but we don't catch it. We don't do anything about it. The young men and young women are left to struggle. That, to me, is more serious. All right, so type 2 error. There is a difference, but we don't catch it. All right, we don't catch it and they don't get the help that they need. Okay, so I'm going to go back and I'm going to add in more details to this worksheet and I will publish it. Is that the right word? Sure, why not? I'll put it on my blog for all to see. Till next time, Stat World! I think my neighbors like that.